Bismillahirrahmanirrahim. Dear students, how are you? This is our lecture number 36 regarding the reaction dynamics 4146 and 4146. If any difficulty in the previous lecture, you can discuss. Now, today we will discuss some basic experiment of kinetic study. Okay, how we can study the kinetics of various reactions. Dear students, to make an experimental study of the kinetics of a reaction, certain parameters must be taken under consideration. That is, temperature, for example, must remain same throughout the experiment as the rate constant as the rate constant must remain same throughout the experiment as the rate constant is dependent upon temperature. That is, to make experimental study of kinetics of reaction, certain parameters must be taken under consideration. That is, temperature, for example, must remain same throughout the experiment as the rate constant is dependent upon temperature. Similarly, if two solutions are mixed together for the reaction to take place, the mixing should be homogeneous. Similarly, if two solutions are mixed together for the reaction to take place, the mixing should be homogeneous. Stoichiometry of reaction should be well established. Kinetics of slow reactions can be monitored by, by conventional methods, whereas modern techniques have been introduced in order to study the kinetics of fast reaction. Uh, Now we will first discuss the kinetics of slow reactions. Dear students, slow reactions take place at moderate rate and their rates can be determined either by determining the concentration of one of the reactants or products at equal intervals of time, or by monitoring some physical property of any of the reactants or products that is directly related with concentration. Once again, slow reactions take place at moderate rate and their rates can be determined either by determining the concentration of one of the reactants or products at equal intervals of time, or by monitoring some physical property of any of the reactants or products that is directly related with concentration. The former method is discontinuous chemical method. The former method is a discontinuous chemical method known as direct sampling technique, for example titration, whereas the later is a continuous method, physical method, whereas the later is a continuous physical method termed as indirect sampling technique, for example, measurement of absorbance as a function of time. Now, dear students, slow reactions take place at moderate rate and their rates can be determined either by determining the concentration of one of the reactants or products at equal intervals of time, or by monitoring some physical property of any of the reactants or products that is directly related with concentration. The former method is discontinuous chemical method known as direct sampling technique, for example titration, whereas the latter is a continuous physical method termed as indirect sampling technique, for example the measurement of absorbance as a function of time. Now first method is the polarimeter. Now dear students, polarimetry was introduced as a physical and continuous method in 1837. Wilme, for the first time in 1850, studied in detail the progress of hydrolysis of sucrose in acidic solution using polarimetry. Now, those substances which are chemically active, they can be studied by the method of uh, polarimetry. In this, we change measure the angle of rotation with passage of time. Sorry. Polarimetry was introduced as a physical and continuous method in 1837. Wilmer, for the first time in 1850, studied in detail the progress of hydrolysis of sucrose in acidic solution using polarimetry. For example, sucrose in presence of acid is converted into glucose and fructose. Sucrose in presence of acid is converted into glucose and fructose. In this reaction, sucrose, glucose, and fructose are optically active species, but sucrose and glucose are dextrorotatory, whereas fructose is strongly levodopa. That is, substances rotate the subst- uh, in this reaction, sucrose, glucose, and fructose are optically active species, but sucrose and glucose are dextrorotatory, whereas fructose is strongly levodopa. The substances are two types. One is dextrorotatory, other is levorotatory. The substance which rotates the angle towards positive direction, the right, is called dextrorotatory, whereas the substance which rotates the angle of rotation towards the negative is called levorotatory, yeah, towards the left. In the start of reaction, when concentration of sucrose is greater, the value of angle of rotation is positive, which decreases with the decrease in the concentration of the reactant and increases in the concentration of products, and after passing through zero it becomes net. That is, in the start of the reaction, when the concentration of sucrose is greater, the value of angle of rotation is positive, which decreases with the decrease in the concentration of reactant and increases in the concentration of the product, and after passing through zero it becomes negative. Hence the angle of rotation is directly related with the concentration and can be used to monitor a reaction involving optically active substances. Now dear students, in this reaction sucrose, glucose and fructose are optically active species, but sucrose and glucose are dextrorotatory, whereas fructose is strongly levorotatory. In the start of the reaction, when the concentration of sucrose is greater, the value of the angle of rotation is positive, which decreases with the decrease in the concentration of the reactant and increases the concentration of products, and after passing through zero it becomes negative. Hence the angle of rotation is directly related with concentration, concentration and can be used to monitor a reaction involving optically active substances. Uh, Second technique is the conductimetry, that is the measurement of conductance is called conductimetry. Conductimetry is used to monitor reactions which proceed with a change in the number of ions involved. That is, conductimetry is used to monitor the reactions which proceed with a change in the number of ions involved. The change in the number of ions in the reaction in, in the reaction vessel causes variation in the conductance of the system. That is, change in the number of ions in the reaction vessel causes variation in the conductance of the uh, system. For example, the reaction between acetic acid and sodium hydroxide in aqueous solution can be monitored by conductometry because the conductance of the solution decreases with the passage of time due to the consumption of hydroxyl ions as shown in the following reaction. That is, acetic acid CH3COOH plus NaOH, it will form CH3COONA, sodium acetate plus water. Now once again, conductimetry is used to monitor the reactions which proceed with a change in the number of ions involved. The change in the number of ions in the reaction vessel causes variation in the conductance of the system. For example, the reaction between acetic acid and sodium hydroxide in aqueous solution can be monitored by conductometry because the conductance of solution decreases with the passage of time due to consumption of hydroxyl ion as shown in the following reaction. Dear students, the reaction is acetic acid. It will react with sodium hydroxide to form sodium acetate and water. Third technique to monitor the flow reaction is dilatometry. Is a dilatometry. Dilatometry is a technique used for monitoring the reactions which proceed with change in volume. That is, this technique is used for monitoring the reactions which proceed with change in the volume. Dilatometer shown in figure below is used for this purpose. That is, this technique is used for monitoring the reactions which proceed with change in volume. Dilatometer shown in the figure below is used for this purpose. The reaction is carried out in the sample well of dilatometer and rise or fall in the aggregated capillary of the dilatometer with the passage of time is noted to study the kinetics of reaction. For example, CH3 twice C double bond CH plus CH plus water, it will form CH3 thrice CO. The volume of the sample decreases with the progress of reaction due to decrease in the number of moles of the system. So by measuring the change in volume, we can study the progress of the reaction. Fourth technique is the manometry. Fourth technique is the manometry. The reactions involving gases can be monitored by measuring the change in total pressure using this technique. That is, the reactions involving gases can be monitored by measuring the change in total pressure using this technique. One such reaction is the catalytic hydrogenation of ethene, which is shown below. That is ethene CH2 double bond CH2. It will combine with hydrogen forming ethane. In this reaction, total pressure of the system decreases with the progress of the reaction. In this reaction, total pressure of the system decreases with the progress of reaction. The decrease in pressure is directly related to the concentration of the product. Now, dear students, the reactions involving gases can be monitored by measuring the change in total pressure using this technique. One such reaction is the catalytic hydrogenation of ethene, which is shown below. That is, ethene will react with hydrogen forming ethane. In this reaction, the total pressure of the system decreases with the progress of reaction. The decrease in pressure is directly related to the concentration of the product. Now, here two diagrams are shown. Figure 5.20 is reaction monitoring by conductive meter. This is the conductive meter. This is the, you can say, the thermos reaction vessel, or beaker is the thermostat, and a conductometer is inserted in the reaction vessel, and with the passage of time and the conductance is measured directly from the conductometer. Second is the reaction monitoring by dilatometer. Here dilatometer is used to monitor the change in volume. Now, this is sample work. Beaker is the thermostat, and there is a capillary tube. With the passage of time, change in volume in the capillary tube is measured, and which is directly related to the concentration of the reactant or product. Fifth technique is the viscometry. Now, Viscometry is used for the reactions in which there is a significant difference in the viscosity of the reactants and that of the product. That is, viscometry is used for the reaction in which there is a significant difference in the viscosity of the reactants and that of the products. Uh, where here I N propyl acrylamide. This is the monomer. It polymerizes and the viscosity of the polymer is higher than the acrylamide solution. So, the monomers N isopropyl acrylamide solution is comparatively less viscous than the polymer it forms. Hence, with the progress of polymerization, the viscosity of the reaction mixture increases, showing an increase in the concentration of the products. Therefore, viscometry measurement, viscosity measurement can be used to study the kinetics of this reaction. Fourth one is the pH meter. What is pH? pH is negative log of hydrogen concentration. That is, pH is equal to minus log of H positive ion concentration. Similarly, pOH is negative log of OH ion concentration. Now, sum of pH and pOH is equal to 14. The change in pH can also be monitored. Change in pH can also be used to monitor the progress of a reaction. For example, hydrolysis of alkyl halides can be monitored by pH measurement because the formation of HCl in the reaction mixture decreases the pH with the progress of time. A general reaction is given below. RCl, that is alkyl halide, uh, it reacts with water to form ROH plus HCl. Seventh technique is the spectrophotometry. This is very important technique to study the kinetics of a reaction. So, spectrophotometry is widely used to monitor the reactions in which one of the reactants or products or both are UV active. In the latter case, there must be a significant difference between the wavelengths of maximum absorption of the two. Uh, the reaction between KMnO4 and oxalic acid is shown below. That is, oxalic acid react with KMnO4 in presence of 2O, 2KH, K2SO4 plus MnSO4 plus 8H2O plus 10CO2. Where KMnO4 is only species that absorbs strongly in the visual range and shows lambda max of 532 nanometers. Hence, with the progress of reaction, hence, with the progress of reaction, the absorption of reaction mixture decreases, showing a decrease in the concentration of KMnO4, and thus reaction can be monitored by recording the absorbance at equal intervals of time. Another example of such a reaction is the reduction of sorry the reduction of para-nitrophenol in the presence of sodium borohydride to form para-hydroxylamine. In this reaction, both the reactants and products show absorbance in the UV range, but there is a significant difference between lambda max of the two, that is, the lambda max of para-nitrophenol is 400 nanometer and that of para-hydroxylamine is 300 nanometer. At any time, the absorbance of the reaction mixture is sum of the at any time the absorbance of any absorption of the reaction mixture is sum of the absorption of the reactant and the products at that time, and also that the solvent used. The point at which the absorbance of the species present in the reaction mixtures are same is termed as the isobactic point. Now, dear students, the spectrometry is the important techniques used to monitor the progress of the reaction. Thank you.